Hi everyone, this is Chris. Welcome back to our site engineering tutorials. Today we're going to go over how to create a contour map utilizing a site level and tripod while measuring elevation across a grid. You'll be using many of the same techniques that we learned in the last tutorial in measuring elevation, as well as how to lay out a landscape grid utilizing a right triangle, which will form the basis of the rest of our grid, which will then allow us to form our contour map. By measuring and plotting elevation points across this grid, we'll then be able to use the process of interpolation to find out where exactly those contour lines are. Before we get to plotting contour lines, though, we have to create the framework upon which those contours will be based, the landscape grid. To do this, we'll be laying out a right triangle at a 3-4-5 ratio, which will give us the 90-degree angle we need in order to expand our grid. To start this process, we'll lay down two sides of the triangle, one at 40 feet and the other at 30 feet. During this phase of the setup, it's important that you sight this angle along the landscape in the direction that you want the grid to go. Once these two sides are staked down, we'll then walk the hypotenuse of the triangle at 50 feet. By joining the 50-foot tape to the 30-foot side of the tape, we create the 90-degree angle that we need. At this point, we'll extend the two sides of the triangle to 50 feet. This will allow us to now begin creating our first grid square, which will then eventually create the larger grid. For the purposes of our exercise, we'll be laying out roughly 1 acre at 200 feet by 200 feet, or 4 grid squares by 4 grid squares, if each grid square is 50 feet by 50 feet. After you've extended the sides of the triangle to 50 feet, making sure to keep alignment with the previous chain pins you set, you'll proceed to pin those sides down and walk another 2 lengths of 50-foot tape out. Where the two ends meet at the 50-foot mark, this forms yet another right angle and your first grid square. To form your next grid square, you'll walk another 50 feet, keeping alignment with the chain pins you set previously, pin that side down, and by walking yet another 2 lengths of 50-foot tape, just like before, we create our second grid square. At this point, the process of creating the grid speeds up, as we're able to walk out longer lengths of tape while keeping alignment. We're able to close our grid 1 square at a time. Once our grid is complete, we're ready to start measuring and plotting our elevations. In order to do this, we'll need to label our grid so that we can recall where these elevations are after they've been made. Typically, one side would be lettered and the other numbered. As we measure, we'll be plotting our elevations according to the grid squares, starting with A1, moving to B1, C1, D1, and E1, for example. Each grid square is referred to by where the letter and number intersect at its upper corner. If we were to go back from E1, we'd reach E2, D2, C2, B2, and A2, so on and so forth throughout the entire grid. This would be a good time to pause the video and see if you can call out this grid square. Intersecting at the B and 4, we have grid square B4. Now be careful here at the back of the grid, as it can easily be confused with something like B5. While there is no grid square for B5, there is a point of elevation. Now at this point, things should start to get a bit more familiar, as we're ready to find our benchmark and take our first backsite measurement. Having gone back to our assigned benchmark at the top of the curve from the last tutorial, we know we start at 100 feet of elevation. After calculating the height of instrument by adding the backsite to the elevation, we reach 101.07 feet. There'll be a few other things that are familiar to you. The points column remains the same as we place BM for benchmark, BS for backsite, HI for height of instrument, FS for foresight, and last one, elevation. We've also added a remarks column at the end. The rod will be doing quite a bit of moving around, and this column is for anything worth noting. Now, as you may have noticed, there's a new addition at the center of the page. IFS stands for Intermediate Foresight. This is a measurement much like our regular foresight in that it looks forward to an unknown elevation. Unlike our regular foresight, however, the instrument will not be moving after every measurement. Instead, the sight level and its operator will sight as many locations on the grid as possible from that single location, logging each one separately from our regular foresights. Should the operator come across a grid square where the measuring rod is no longer visible, they will stay put and attempt to record as many other measurements as they can from their current position. When no other measurements are visible, the operator will move the tripod and sight level to a new location they feel will provide the most visibility to the most measurements. In this way, the process is a bit like a game, where the goal is to strategically move as little as possible, while obtaining the most amount of measurements until every grid square's elevation is recorded. We'll get more into how this process works a little later. In the meantime, it's time to record our first intermediate foresight measurement. After your intermediate foresight is recorded, it's time to establish the elevation for that grid point. Here you'll find yourself in familiar territory. Rather than the height of instrument from the previous line being subtracted by a foresight, you'll simply subtract the intermediate foresight instead. With the elevation recorded, we can continue measuring the grid, recording intermediate foresights. With this intermediate foresight recorded, go ahead and pause the video and apply the revised formula to obtain the elevation for C1. After entering this measurement, I continue across the grid so that Rich can grab a measurement for D1. Setting up, Rich sights the rod and very quickly realizes that he no longer has a sight line. In this case, the rod has now moved ever so slightly above the sight level due to a subtle rise in elevation. Rather than move the sight level immediately, however, Rich proceeds to grab another shot in the next row at A2. After entering the intermediate foresight and calculating the elevation, Rich then attempts to measure B2. Unfortunately, this is the same case. There is no sight line, so Rich picks up the sight level and moves on to a better location. Now, while Rich is setting up, he's asked me to return to grid point C1 to take another measurement. This is because he will need a new backsight in order to establish the new height of instrument from his new position. Given that C1 is now a known elevation, thanks to our intermediate foresight measurement, and fairly close to the new setup, I'll wait there and revise the notes to accommodate the move. Looking back at our notes with the new backsight in mind, I'll separate the previous measurements from the old location and transfer C1's information down to begin the next series of notes. In doing this, I cross out the measurement and elevation we made before and make note of it in the remarks column. One important thing to note is that when using an intermediate foresight to provide a backsight for a new setup, the measurement becomes logged as a regular foresight, not an intermediate foresight. This is important as it means it will now be counted in our math check at the end. With the new backsight entered, we'll now obtain the new height of instrument with the equation we've been using in the past. Going forward in measuring the rest of the grid and logging them in our leveling notes, Rich will proceed to obtain the intermediate foresight measurement that we were unable to obtain before. Afterwards, he'll systematically move, getting more intermediate foresight measurements throughout the grid until the grid measurements are complete. Should he be unable to obtain any measurements due to his location, there would be another tripod and sight level move, and the notes would be accommodated in the same way. Looking back to our notes, let's take a look at what the rest of the grid measurements were. As you may have noticed, the notes reflect that we did end up having to move the sight level one more time in order to obtain the elevation for one remaining grid point. This is noted in the remarks column as well as signified by the crossouts on row C4. Looking down at the bottom, we can see that within our sight boundary, we ended up at a final elevation of 77.06 feet. Having completed our notes, we'll need to do our math check to ensure we made no errors while calculating our heights of instrument and our elevations throughout the differential leveling process. At this point, it's important to remember that while the list of numbers may seem daunting, intermediate foresights do not get counted in the math check. As we did in the last tutorial, all we need to do is subtract the sum of our backsights by the sum of our foresights, and compare it to the sum of our final elevation subtracted by our starting elevation. Since the numbers match up, we're ready to start plotting our elevations on the grid. In our next tutorial, we'll be showing you how to take your leveling notes and translate them into contour lines via the process of interpolation. So, till then.